An earthquake this morning strikes in nearly the same spot as one yesterday. KPIX5's Emily Turner tells us the twin quakes happened during a week.
On July 29th, 2025, the entire world changed, rather than just the ground shaking. At 11:24 a.m. local time, an 8.8 magnitude earthquake struck off Russia's Kamchatka Peninsula. In seconds, it released enough energy to change the Earth's rotation, tilt its axis, and set off a chain reaction of volcanic activity that scientists are still investigating. This wasn't simply another earthquake, it was a unique occurrence powerful enough to leave a measurable mark on the planet. The quake's epicenter was 119 kilometers east-southeast of Petropavlovsk-Kamchatsky, on the famed Kuril-Kamchatka subduction zone, one of the most active fault lines on the planet. The vast Pacific plate constantly grinds beneath the North American plate, accumulating immense stress until it snaps. According to the USGS, the rupture zone was approximately 480 kilometers long and 160 kilometers wide. Along this fissure, the Earth's crust slipped by up to 9 meters, or the height of a 3-story skyscraper, in just seconds. Because the quake occurred only 20 kilometers beneath the seafloor, the tremendous movement pushed large amounts of water upward, immediately sparking Pacific-wide tsunami warnings. From Alaska to Chile, Japan to California, the Pacific Rim braced for an impact. But what happened next was both less devastating and considerably wilder than anyone had anticipated. When the alerts were issued, the globe braced for disaster. The entire coastline from Alaska to Chile has been prepared for water walls. Fortunately, the waves were smaller than the worst predictions. Most places had surges of roughly 1 meter, enough to cause evacuations, but not widespread destruction. However, near the epicenter, the story was completely different. On Chumshu Island, a 19-meter surge swallowed piers, lifted fishing boats like toys, and hurled them deep inland. Water rushed more than 200 meters above the beach in many Kurilsk communities, destroying a fish facility and causing entire neighborhoods to escape. Russian officials evacuated around 2,700 people. And here's the amazing part. Despite the magnitude of the earthquake and tsunami, just 4 persons sustained minor injuries. There were no fatalities reported. Engineers cite decades-old Soviet building rules and frequent safety exercises, which proved to be a concealed disaster prevention measure. But the earthquake's impact extended well beyond Russia. In Japan, hundreds of kilometers away, evacuation orders clashed with a punishing heat wave. Dozens of people were hospitalized with heat stroke, and one unfortunately died in a road accident while attempting to leave. It served as a reminder that a megaquake's shock waves travel beyond the ground and into the water. They disturb entire human systems. However, what scientists uncovered next was even more shocking. This earthquake did not simply shift individuals. It shifted the globe itself. As the immediate threat passed, scientists shifted their focus to something considerably odd than collapsing buildings or damaged harbors. The underlying narrative was not obvious on the surface. It was hidden among the data from satellites and atomic clocks. This earthquake did more than merely breach the crust. It displaced the Earth's mass. Here is what that means. When large volumes of rock suddenly move, the planet's balance shifts. Like a figure skater straining up their arms to spin faster, the Earth began to rotate somewhat faster. In fact, the Kamchatka earthquake cut the length of a day by a few microseconds, too small for humans to feel, but very real for precision tools. It also shifted Earth's figure axis, which is the equilibrium point of its internal mass, to a new place. It displaced by roughly 14 centimeters as a result of Japan's massive earthquake in 2011. Chile's 2010 earthquake displaced it by around 8. The Kamchatka breach most likely resulted in a similar migration. Entire areas of southern Kamchatka shifted more than 2 meters southeast in an instant. Headlines immediately reported that the Earth was wobbling, or that its tilt had shifted. However, experts were quick to point out that the planet's axial tilt, which determines our seasons, stays constant at 23.4 degrees. That is beyond the reach of an earthquake. Only an asteroid strike would do. Nonetheless, the notion that a single earthquake may alter Earth's spin and disrupt its internal balance is remarkable. When researchers reviewed the data, they realized it wasn't simply another seismic event. It was one of the most accurately measured planetary jolts in history. Geoscientists saw this earthquake as more than a natural calamity. It was a planetary-scale experiment. Never before had so many instruments been perfectly aligned to detect a megathrust earthquake in real time. GPS arrays, ocean buoys, seismic observatories, and satellites all captured the rupture as it occurred. What was the result? A data set unlike any that scientists had ever seen. With this information, researchers may improve models of how the Earth's mass shifts, tsunamis spread across oceans, and the planet flexes under extreme stress. It also improves GPS accuracy, tsunami warning systems, and climate models based on Earth's rotational stability. In other words, it was more than just comprehending earthquakes. It was about understanding how the Earth responds to dramatic change, and how that response affects the systems on which humans rely. Despite the spectacular headlines, scientists emphasize an essential aspect. The Earth remains stable. These changes, however significant, are absorbed by the planet's natural equilibrium. The day may be a little shorter, the axis slightly changed, yet life goes on uninterrupted. But this is where the story takes a turn. While seismic forces can shake the world in a moment, people are silently and permanently modifying Earth's balance in ways that may be even more significant. The Kamchatka earthquake demonstrated how natural forces may change the Earth in an instant. But here's a surprise twist. Humans are also changing Earth's balance. Studies suggest that increased groundwater extraction, particularly in Asia, has changed the planet's figure axis by roughly 80 centimeters since the 1990s. That is more displacement than many of the world's most powerful earthquakes combined. And it does not end there. Melting glaciers and increasing sea levels are gradually rearranging Earth's mass. Unlike earthquakes, which strike and then settle, these shifts are gradual but continual, permanently affecting how our world spins and balances. Nonetheless, the Kamchatka event remains extraordinary. It was like a natural experiment we could never plan or replicate, but it revealed Earth as a dynamic system that groans, flexes, and recalibrates in response to both natural and human pressures. Imagine the Earth as a massive tuning fork. Each megaquake impacts it, causing vibrations throughout space and time. For scientists, such vibrations provide insights that help us comprehend anything from tectonics to climatic stability. And while most of us go about our daily lives completely unconscious, the rhythm of time itself is gently shifting beneath our feet. The Kamchatka earthquake did more than merely rattle structures. It changed the rhythm of time itself. Satellites recalibrated, atomic clocks ticked a little faster, and our planet rotated somewhat differently than usual. For scientists, it was confirmation that the Earth is never static. It's alive, changing, and rewriting its tale beneath our feet. For the rest of us, it is a sobering reminder. We live in a world that may change in an instant, sometimes in ways we can't feel. If this story has given you a fresh perspective on Earth's secret power, stay interested with us here at Geosphere. Because if a single earthquake can alter time, consider what happens when volcanoes erupt, ice sheets melt, or tectonic plates clash. Watch our next episode to explore how these forces continue to shape the planet we call home.